So the exercise I'm going to present you will be available on the Jupyter Hub, and you will find on the Jupyter Hub the same way as Julia presented you just before, and you will also find on the Padlet, so on the WEkEO material that you have on the top of your screen. Save the link, please do it. You will find all the information to access this exercise. So, oops. Right now, the notebook is not available yet. We are going to upload it at the end of the week probably, but I'm going to present you what it will look like. Before we start, I would like to point out that this great exercise has been developed by a colleague of mine, Alexandre, and so all the reward must be addressed to him. Yeah. Once you reach the Jupyter Hub, you have to pay attention and to use the right kernel to have the good environment, and the one you need is the mini WEkEO lab, this one. Yep. And so, yeah, Julia already told you everything about how Jupyter notebooks work. So to run a cell, you have to click on the arrow, or to use the keyboard shortcut Shift and Enter. You can restart the notebook if it doesn't work, thanks to the restart kernel here. And I think that's all for the introduction to Jupyter notebooks. Here's the program of the exercise. So I'm going to introduce you to the subject of the exercise, that are droughts of summer 2022. Then I'm going to present you the libraries, the Python libraries we will use. We will teach you, although Julia already presented you an extensive presentation of this, we will show you how to open and explore some data. We will study the snow deficit in northern Italy, the precipitation anomalies in Italy, again, and then we will visualize the consequences of the droughts over the Po River thanks to satellite images. So that's it for the program of the exercise. So if you live in Europe, or if you watched the news last summer, you have probably learned that Europe suffered a very intense drought period in summer, well, last summer. This drought was due to low precipitations and very long heat waves, and it covered, well, the whole Europe suffered from this drought. On this map from the European Drought Observatory, you can see that all the indicators showed that the drought was very severe. So you have several parameters that are the rainfall deficit, soil moisture, vegetation stress, etc. So all the parameters indicate that the drought of July 2022 was very intense. So droughts have, of course, very negative impacts on many aspects. They have consequences on the water availability, on hydroelectricity, on agriculture, of course. And because these events are expected to become more likely and more severe due to global warming and climate change, it's crucial to learn how to assess their impacts and to assess such events. So this is what we're going to learn in this notebook. We're going to learn how to measure hydrology parameters thanks to the WEkEO portal. And that's it. So we're going to use basically the same libraries as Julia presented you just before. So these are very basic libraries for Earth observation. We're going to use NumPy, Xarray, Matplotlib, Cartopy, Rasterio, and GeoPandas. On this table, you can find the link to the documentation of each library. Besides, they are very commonly used libraries. So on the internet, you can find plenty of examples of of how to do maps, etc. And if you have any question, you can also send a message to the user support. So you should have everything you need to do whatever you want with the WEkEO data. So here on this cell, we import all the libraries. And then we can start exploring some WEkEO data, starting with some ERA 5 model. So the model we're going to use is the ERA 5 land monthly average data from 1950 to present. So this product is a reanalysis data set. It combines the advantages of a model with the advantages of some observations. So it's a very reliable product. If you click on the link here, you will access plenty of information about the product. So yeah, don't hesitate to have a look at this page. And the variables that we're going to study here are the total precipitation, the snow depth, and the snow density from January 2000 to December 2022. Here are some information about the product. We have the spatial and temporal resolution and temporal coverage as well. So if you need to download the data, so yeah, Julia already showed you plenty of things. You can, of course, download it through the data viewer, selecting the bounding box, the variables, etc. So Julia already showed you this. But in this notebook and in this workshop, we would like to teach you how to download the data directly from Python, thanks to the HDA Harmonized Data Access API provided by WEkEO. On this cell, as Julia said before, you need to be registered to the WEkEO service to access the data. And thanks to this cell, the notebook will know how to access your username and password. So if you run this cell, the cell will ask you to enter your username and enter your password, and then you'll be all set to download the data. What we're going to do is that we're going to download the file thanks to a request, exactly the same as Julia showed you before. If you select all your parameters on the data viewer and then you click on show API request. So of course I didn't select anything here, but if you select your parameters, you will find all the data you need. And here the request we have for our study is already available in the Jupyter notebook folder. It's called era5rec.json. If you right-click on it and open with the editor, you can access all. But you can also see what's in it thanks to this little cell. And here you can see we download the years from 2000 to 2022 and all the months below. For this presentation, I'm not going to download it in real time because it takes some time and I want to save time to present you plenty of things. But if you uncomment the following lines you run the cell, the ERA 5 land dataset will be downloaded here in the data folder on the ERA 5 land folder, etc. Well, fine, you shall retrieve exactly the same folder as me. If you explore if you have a look at the request, you can see that we have asked to download the file in the GRIP format. That's something we choose for the notebook to be more convenient. And if you try to open the file with the xarray, which open dataset function, you will find, well, you will need first to specify that you're going to open a GRIP file. So you have to put this. But if you run this cell, you will have an error and the code will advise you to add one of the following keys. So filter by keys, you have 4 options, and we're going to use the 4 options. And actually, for each of the filter by keys option, you will retrieve one part of the dataset. So I'm not going to be very extensive on this. The text is very clear, and I want to spend more time on presenting you the results. But with the first filter by key option, we have the precipitation from 2002 to we have the precipitations from 2002 to 2022. So that's the first option. If we do with the second option, you will see that we have, again, the precipitation. You can see TP here refers to total precipitation. So yeah, here it goes from 2000 to 2002. So if we concatenate the first 2 files, we will retrieve, that's what we do here, we will retrieve the total precipitation for the whole period that we wanted. Then we open with the third option in order to retrieve the snow depth. Again, if you have a look, you have the snow cover and the snow depth in these 2 variables. And yeah, so the snow depth is divided into 2 step values, but if you have a look at the notebook, it will explain you how we can fix this issue. And finally, if we open the with the fourth option, we will retrieve the snow density. Here, RSN stands for, if you check, snow density. Okay, so now we have our 3 data set. We have the total precipitation, we have the snow depth and the snow density, all ready for us to explore. If you need to select a variable, well, one of the main things you need is to manipulate the X-array dataset. If you want to select one variable, let's say time, for example, you just have to put the name of the variable between brackets. Here, if you run this cell, you will retrieve the values of the time. If you want to select one date, one exact date that's included in the dataset, you have to use the .cell method and put then time equals the time you want. And if you run this cell, you will see that now the cell does not have time as dimension. The dataset do no longer have time as dimension. We only have one date time, that is June 2022. If you want to select a date, but the date is not included in the dataset, for example, if we would like to have the 5th of June, it's not possible because the dataset only takes the 1st of the month, so it wouldn't work if we remove. You will see you have an issue if you run this cell, but if you put method equals nearest. Well, maybe I shouldn't have done this. Okay, I promise you it works. Sorry, because I would have to run the previous cells, but I will follow on. And one last method you can use if you want to select a date from its index. If you want, for example, to take the 9th date time, you have to use the .icell method. And here you have the result, and the 9th date time will refer, as you can see here, to October 2000. So that's it. Finally, if you want to select a time range, you can use the slice method. So again, you still use the .cell method and slice. Here we take from the 1st of July to the 31st of July. And because there's only one date between these two dates, you will have again one date time. Okay, so now we have seen how to explore dataset, how to select variables, to select only one date time. Of course, you can apply it to any other dimension, longitude, latitude, etc. You can subset your dataset as you want. And now we are going to plot a map. We're going to plot the total precipitation over Europe in October 2020, according to this product. So first, we defined the area of interest of Western Europe. So these are the coordinates of the bounded box we want to plot. And so what I would like to do is first to show you the figure and then to explain you how it's been constructed. So that's what I'm going to do here. The result is this. So we have a map of the precipitation on October 2020 over Europe. Kind of easy. What we do is that first we defined the date we want to plot, so October 2020. We select the total precipitation. As we have seen before, it's called TP in the dataset. Then we select the date with the method we have seen just before. Then we use some matplotlib functions to create knife figures. So here we create the figure, we add the coastlines, we add the grid lines, we remove the labels on the right and on the top, we add the landmass, and we set the extent according to what we have defined before. Then we use the pcolor function to display the precipitation. We add the title, the color bar, and set the labels. If you want, you can save the figure. And that's it. So we can see on this picture, this figure, the regions where the precipitations were the highest, and it seems to be in the Alps in Italy. So this is the region that we are going to study. We're going to study now the snow in northern Italy. Italy is one of the countries that particularly suffered from the droughts of 2022. And one of the reasons for this drought is the snow deficit in the Italian Alps. If you click on this link, you will have a EUMETSAT article that covers the subject. And now we're going to see how, with the ERA5 dataset, the one we just downloaded, how we can observe this event. The first thing we want to know is to extract the data in Italy. As you have seen before, we downloaded the data for all European continents. So we want now to select only Italy. And to do so, we are using a shapefile from Eurosat. And it's again, it's stored in the data folder of the notebook. If you run this cell, you will observe all the information of this data of this shapefile. So you have all the countries and many parameters that describe the countries, and one of them is name English, which we are going to use to select Italy. So if you run this cell, you will find the information about Italy. The parameter that we are interested in is the geometry that gives the coordinates of the polygon that describes Italy. And if you run this cell, we will color Italy to verify that we are watching the right region. So it looks like Italy. And to plot this map, we use the dot plot method. That's it. We are going now to extract the data sets that we have. So the precipitation, snow depth, and snow density, we're going to subset them to study only Italy. So that's what we do in the two cells here. At the end, we have the precipitation snow depth and snow density only in Italy. And we are now all set to monitor the snow cover in Italy. So first we'll have a look, we'll create a map of the snow depth in Italy in January 2022. So again, first I show you the map and then I show you how we constructed it. So here is the map. So you can see there are more snow in the Alps, and we have no snow near the coast. So how did we build this figure? Again, we selected one date. We selected the snow depth from our data set. We selected the time as well. We applied this filter so that if the snow depth was equal to 0, it is not displayed on the map. So it appears in gray. Again, the characteristics of the plot. P-color function to plot the region where there's depth, and titles, legend, and say figure. So that's it. What we are going to see now is we're going to calculate the snow water equivalent, which is a parameter that describes the depth of water that would be if all the snow melted. So this parameter is calculated multiplying the snow depth per the snow density, and then you divide it per the volumic mass of water. That's the formula. That's what this cell does. And we can plot the evolution of the mean Italian seawater equivalent over the last 20 years. So this is what this cell does, and that's the result of the figure. What we do here is that we calculate the mean. So we have calculated the seawater equivalent, and we average it with the dimension latitude and longitude. So we only have a value that depends on time, and we can plot with Matplotlib. It's kind of easy. So what we can see from this figure is that although 2022, the winter 2022 was not the least we've had over the last 20 years, it's still pretty low compared to some previous years. And so this is one of the reasons why that explains the droughts that occurred in summer 2022. That's because there was not as much snow in the Alps as for the previous years, but we've had droughts in summer. Now we're going to study the precipitation deficit in Italy in 2022. So we're going to plot the anomalies because besides the low snow, we also had low precipitation in spring 2022. So what we're going to do is that we're going to compare the last 3 years, so 2020 to 2022. And we're going to compare these 3 years to the last 20 years, so from 2000 to 2019. On this cell here, we select, we're going to study only the month of May. So we compare May 2022. That's what we do here. We select May 2022, and we compare it to May. So that's here we select only the month of May, and here we select the month of May for the years 2000 to 2019. Then we can subtract, plot the difference between these two dates. And again, I'll show you the map. Here you have the precipitation anomaly between May 2022 and the average of May from 2000 to 2019. That's how we go. So as I said, you subtract the two datasets that we have defined. you define the characteristics, the landmass, etc., the color to plot the anomalies, titles, and legend. So the first analysis we can make on this map is that obviously the precipitations lacked in, well, over almost all the Italian region, and especially in the Alps. We can see very low values here, very high anomaly. And so what we are going to see now is that we're going to see, this is just for the month of May, and we're going now to study for, well, month by month, we're going to see how it evolved. So again, we are going to select the historical reference data set. So we select the precipitation in Italy from 2000 to 2019, as before, regroup by month. And if you have a look at the result of this, you can see that we have one value per month. And for each month, you will have the mean, the temporal mean over all the years for each latitude and longitude. Now we do the same, but for the last 3 years. Well, we don't compute any mean, but we select from 2020 to 2022. And for these two data sets, so the one, the historical one and the last 3 years one, we can calculate the mean so that, again, we only have a value that depends on time. We calculate the mean over longitude and latitude. And, well, again, I'll show you the chart first. It will be easier to explain. What we are plotting now is that we compare for each month from January 2020 to December 2022. We compare each month to the historical mean 2019. So to do so, we are using the dot bar function from Matplotlib, and we set the labels, etc. And so again, as we can see, the last 3 years have been very low, very well. We can observe a very long-lasting deficit in precipitation, and especially in 2022. So this analysis, the low precipitations combined with the low snow depths, explain why the summer 2022 experienced a very severe drought. One last analysis about the precipitation. We're going to compare the yearly distributions. Again, I show you the figure first. So that's the figure that we're going to plot. To plot basically, what we plot is the almost the time series of the precipitation, except that the months are sorted by so that the curve is only increasing. So that's what we do here. On this cell, first we sort the months so that the curve is keeps increasing. And the result, the analysis that we can make is that, again, 2022 seems to be a very exceptional low precipitation year. It's lower than all the 20 previous years. Okay, so now that we have seen why the droughts appear and that we are able to monitor why droughts appear, we can see the consequences on hydrology, the consequences on river flows. And we're going to use satellite images, and we're going to focus on a smaller region of Italy near the city of Cremona. And that's it. And we're going to use the Sentinel-2 images with a resolution of 10 meters. And we're going to use 2 dates. But first, let me show you how you can download the file. As David said before, the requests for Sentinel-2 don't really work for now, but they are going to be fixed soon. So when it works again, you can use the following cell to directly download the Sentinel-2 images you need. And if you need information, you have the link here to the tutorial that will explain you all you need. So, as I said, we're going to define this small region in the north of Italy where the Po River, which you see here, and where it flows. And so I'm going to present you a little how the Sentinel-2 images work. So because it don't work, the downloading application doesn't work here, we have downloaded it on our site. So we have downloaded two files, one from July 2021 and one from July 2022. And the aim of this analysis will be to compare the 2 years. If you have a look at this these images, you have to go through the granular here, images, 10 meter, as I said, resolution, and you will see that you have several tiles, and we have a little plot about how the Sentinel-2 images work. So the band 2 refers to the blue color, then you have the green color, the red color, and the near infrared color. These are the files that we are going to use. And so here in this cell, first we defined the links to the path of the tiles that I presented to you for both 2002, 2021, 22, 29. We open this file thanks to the raster methods, and then we can visualize the drops. So first, we're going to use all the tiles to have a real image and to compare the two images. That's the result of the cell. So as you can see, the first thing we can notice is that this picture on the left, which refers to 2021, looks more green, whereas in 2022 it looks more yellow, meaning that the soil here is wetter, whereas this one is drier. So that's the first sign of the drought that we can observe. But what we are going to do now is that we are going to see where water, we're going to compute the water mass on the two images in order to compare the flow rate of the river. So to do so, we are using the NDWY, which stands for Normalized Difference Water Index. It's calculated using the near infrared and the green bands of Sentinel-2. And so this is the formula, and this is how we apply the formula to the two data sets. I think that, there's something I forgot to say, is that since January 2022, the Sentinel-2 products have a new processing baseline. They have an additional radiometric offset that is set to 1000. And if you want to compare the two images, you have to apply the offset. So that's what this cell does. In 2022, we apply the offset. So we reduce per 1000 the values. So then the NDWY values will be correct. And here is the result. So this cell shows the mass, the water in 2021, 2022. And we can apply a filter so that we only see the values that are above 0. And here for 2022, for example, this is the regions where there was water. What we are going to do finally is to compare the two masks. So we're going to subtract the two masks. That's what we do here. So we water change this value, we compute the water change, and that's the result. So in red, you have all the regions where we had water in 2021 and we no longer have water in 2022. So the difference is kind of obvious on the figure. And so, yeah, large portions of the riverbank were covered in water in larger portions were covered in water in July 2021. And so this figure highlights the consequences of the droughts over the Po River in the sea. So that's the end of my presentation. So just to summarize what we have learned how to access the Sentinel data, the WEkEO data, sorry, how to monitor the precipitation, the snow, and the snow depth. We have learned how to visualize the impacts of the droughts over the rivers thanks to Sentinel-2 data. And so we propose to use several exercises, so for beginners and for intermediate level, which will teach you how, train you to use the codes we have prepared for you and the data as well. And I think that's it. If you have any problem with the notebook or with the exercises or whatever, do not hesitate to contact the WEkEO support, and we'll be very happy to answer. And I think that's it. I don't know if we have a question, Andrea. You're mute. That's it.
Yes, we do have some questions. Thanks for this very detailed explanation. That was very interesting. It's quite impressive to see the difference between the 2021 and 2022. That is quite alarming. We do have questions, and the first one I will share with you, which is the difference between your calculation and the Euro 5 land snow water equivalent? If you're aware of that.
Question, but yes. Not really. I'm having trouble now with click reading. I don't know why.
Oh.
But
anyway, is the sound we're hearing? Yeah.
I don't know.
Can you see the screen? Okay. Yeah.
I can. I don't know. They want me to show my screen.
Because here we
anyway, I can
see your screen. Okay. I will just read the question. No worries.
That's great. Thank you.
Okay. So next one. The used data are L1C or L2A?
I think they're L2A, but I'm not sure. I'll have to check. I'll answer more precisely in the document we'll provide to you after.
Yes, and you will also be able, just to remind you, that at the moment, like I again said, at the moment the tutorial is not available yet, but at the end of the week it will be on the Padlet, where you will be able to access the document, and you will be able to practice on your own at your own pace, and you will also have access to the recordings of today's and yesterday's session, so you will be able to see it and explore it again at your own pace. We have one or two more questions. Where can we get the data and the script? Okay, yes, that's what I just answered. So later on will also be available, this notebook will also be available on the Jupyter Lab and GitHub, like Julia showed you before. So we're still working on that, but it will come. And I think it's all related to the Jupyter notebook.
That's because people couldn't do it at the same time with me.
Yes, yes, I guess they would have had many more questions, but it would have been very chaotic as well, I guess. So it's better to do one thing at a time.
Yeah, sure. I agree, yes. And anyway, you will, between today and the debriefing session, you will have plenty of time to do it. And if you have questions, I and Alexandre will be back to answer them. So yeah, do not
Exactly.
hesitate to have a look and to ask us questions.
Yes, don't be intimidated by the level if you're a beginner. So give it a try and come with your questions. If there's no stupid questions, so we will all be there to answer your questions. And there's no limit of time. These resources will be available even after the briefing sessions. So, okay, thank you very much again, Ergane.